Okay, we've got two unknowns and two equations. I know this is a system of equations and you're supposed to do stuff like elimination and substitution and all of that, but I'm going to do something unexpected. What could go wrong? Hey, I'm Tammy. I do math for coffee, and I don't think I've had enough coffee this morning, but we'll see how this rolls out. First thing, I'm looking at these things. They're just begging to be factored. I've got the difference of two cubes here. There's a formula for that. And that would be it. A minus b, a squared plus ab plus b squared equals 56. Now, the second one's a little easier. I can just take an a and b out of both of those terms, and we are here. Now, oh man, you see this a minus b and a minus b? I'm going to divide each side by what's underneath it.
All units respond.
And if I do that, I get to cancel the a minus b's. And I'll just reduce the 56 over 16. So we end up with a squared plus ab plus b squared over ab equals 7/2. Coolness. Okay, now what? You can't factor the top. So, but you know what you have here? You have three fractions that had the same denominator. So I'm just going to break those apart. And I'm going to do some more canceling because I like to cancel legally. So I'm taking an a out of the top and the bottom of this one. This guy, oh, that's the same thing. So that's just going to be a 1. And then I can take a b out of the third one. Let's write down what's left. Looks cleaner than what we started with, but we still have two unknowns, and I'm just working with one equation, so somebody out there is going crazy right now. But I know what I'm doing. Watch this. I'm going to just get rid of two unknowns and make it into one unknown. So I now have an equation in terms of x. The reciprocal thing of x is a over b, then b over a has to be 1 over x. Multiply everything by 2x so I can clear the fractions. I'm going to subtract 7x from the 2x on that side, and so we have a 0. Oh, that's always nice. If I can factor that, give me a sec. Yep, there it is. Once it's set equal to 0, you can do the zero product property, and I can solve for x. So I have x equal to 1/2 and x equal to 2. Don't care about x. I'm trying to get to a and b, so we have to bring that back in. Rewrite this as a over b equals 1/2 and a over b equals 2. Oh, a is bigger than b. Go back to the constraints. This is not possible. A is bigger than b, so it's no way it's going to equal 1/2 if you have the a as the numerator. So good. One less thing to think about. Oh, now it's simple. Take both sides by b. A equals 2b. Okay, we're here. We still have two unknowns and two equations, but do we? Go back to the beginning when I first did some factoring on that second given equation. Wherever I see an a, I can now substitute. There it is. We're still going back to substitution. Pop that in there. Okay, I have 2b squared times b equals 16. I'm going to do a couple things at the same time because I can divide both sides by 2. That's going to turn the 16 into an 8. So I've got b cubed equals 8. And since I know b is positive, because it says so right here, b equals positive 2. Oh, a equals 2 times b, a equals 4, and I'm done. That was way more twisty than I expected. That was fun. You want to do another one?